So I was talking about the possible solutions for the current problems. So we thought the first one can be to modify the Bluetooth LE antenna design, and this can be done by using the Friis transmission equation, and it can enhance the Bluetooth signals. And the other one is to introduce a RF or EMI absorber in the system to reduce the transmission power to the Bluetooth LE device. A few corrections were made to the circuit in order to solve all these problems. And the first one we did was to remove the speaker from the circuitry and incorporate a piezo buzzer. Remember, I talked about this earlier that they were not working in cooperation with each other, the speaker and the LED. So the piezo buzzer was introduced into the circuit, and this buzzer is driven by a separate Arduino Uno output, and this one establishes a secondary alarm circuit. The second correction made to the circuit was that, as you know, the applied voltage to the resistor is 4.7 volt, and we were using the original LED that was rated for 4 volts, and this was unfortunately a faulty component, and the voltage drop to the LED was measured at 2.4 volts. So we had to replace the original LED with the other one that was rated at 2.5 volts, and the result was a bright illuminating LED. So these are some problems we have faced so far, and I also talked about some possible solutions for all those problems. We are still working on the project as a team, and for the future, for CN Design 1 and 2, we look forward to minimize the transmission range for Bluetooth. As I talked about it earlier, we want it to be somewhere between 10 and 15 feet, which right now is somewhere around 40 and 45 feet, which is a lot. So we are still working on that one. Also, we are trying to minimize the circuit to a compact wearable watch in the form of a watch or a bracelet, or it can be a necklace too, but it has to be very, very small. So that if you don't want to wear it, you can put it in your wallet, you can put it in your purse, you can either put it with your keys somewhere. So that's the future work. We are still working on it, and we hope to get it through. Okay, this slide shows the price list, the items we have bought so far, and I think we are still in the process of buying some more items as needed for our project. You know, I talked about some solutions. They need some extra components. This is all self-funded. All three of us, we are sparing same time for the project every week. We do our conference calls, and you know, sometimes during the project one person is working on one thing and the other is doing something else. It's usually fairly divided between all three of us. Like for example, I have made the S1P1, and Kana made the first presentation, and David turned it to the IEEE format, and we all worked together to search for the components, for the software, for the circuit design, and now the testing and solving the problems. Also, we attend the conference calls together with the advisor and talk to each other on the phone and discuss things within our team, so that there is no problem and everyone puts the fair share into the work. So this is the final slide of the presentation. It shows the timetable, the dates on which we are planning to complete this and that task. So right now it's the beginning of November. We are done with S1P1, the S1R2, and we have started working on S1R3, and also troubleshooting the problems with the actual circuit and the software that we are facing right now. And we hope to improve the design and the software and write the reports and make the presentation number 2 by the end of the semester. So that's all for now, and thank you very much for listening. I hope we can do even better in the future.